Now, the other thing is, which is advanced material. As I told you, we have another category which is known as advanced material. And this advanced material is not something, a new material, but it is among those material. But these materials are named as advanced material because we use it or you utilize in the high technology application. Now, the high technology application, if today you are asking somebody what is high technology, so they will be saying only the 5G, the NASA people are using the space shuttle and all these things. But previously, like if you go 20, 30 years before, so all these things are, the computer was also a high technology at that time, right? And if you go 10 years before, now even the 10, 20 years, the mobile phone and everything, these are high tech applications. So the CD, DVD player, the computer, right? The fiber optic, the spacecraft, aircraft, military rocketry equipments, all these are high tech applications, right? Of the material. So whatever material we use there are the material on which the functionality of these equipment is based, is known as advanced material. I explained it to you before, like the casing of the computer, which is plastic, is not advanced material, right? So these advanced material may be metal, ceramics, polymer, right? And usually it includes the semiconductor, the biomaterial, right? The smart material and the nano-engineered material. Now, one by one, we will discuss what is the semiconductor, what is the smart material, all these things we will discuss here. Now, semiconductor material, these are the material, they have special electrical properties. By special, I mean like in between the conductor and insulator. They are not, you cannot say they are conductor, they are insulator. They are, that's why they are called semiconductor. In between the two, like in between metal and metal, the metal and ceramics, or you can say metal and polymer. So because polymer and ceramics are bad conductor, are insulator, while metals are good conductor. So the semiconductor are in between these two. Now this characteristic, which is the semiconductance, right? This characteristic of the semiconductor material is extremely sensitive. Sensitive to what? To the impurities. If you put some impurities to the semiconductor material, the conductance, or you can say the resistivity of the material will change, right? And you can control it according to what you want. So if you need high conductivity, you can reduce the impurity. Or if you put more impurity, maybe it will increase. But it depends, like from material to material. But this characteristic, like with the impurity of the atoms, if we put more atoms as an impurity, so the electrical characteristic can be changed. Change like means like we can change according to our desire. Like somehow you can say this is, we are controlling it. So if we are controlling it, then we can make anything we want from the material. And this characteristics and this special properties of the material has revolutionized the world. All the modern equipments, the electrical and electronic equipment you see is based on this semiconductor material, right? So they have a very important role in the human life, or in the society in which we are living, right? The contemporary society, the luxurious society, these semiconductor materials have very important role. And if today you say that if the semiconductor material and all these things, you remove it, the whole society is like Stone Age, you know? So these are very important material. Now the biomaterials are materials which are compatible with the human tissue, which will not affect the human body. So within the human body, sometimes we need some replacement of some organ. Sometimes we need some extra device, right? Because as a human, anything can happen. Like I will give you example of the heart pacemaker. There is one device which is known as heart pacemaker. So if somebody heartbeat is not normal, so the medical doctor, what they do, they put a device here, like in the heart region, which is known as cardiac pacemaker. This cardiac pacemaker, what does it do? It provides pulses to the heart, right? To beat the heart at proper rate, right? Whatever the heart beat we need. So if naturally it is not beating at that rate, so this pacemaker will provide electrical pulses. Now this pacemaker has battery inside, and it is like of the size of, you can say, this 100 fils coin, the Bahraini 100 fils coin, right? Some size of like this, or a little bit bigger. Now these pulses are provided how? The pacemaker is not outside the body. They do a surgery and they put inside the human body that pacemaker, right? Along with the battery, with everything, they put it here, and from here they bring a wire to the heart, right? In some way or something. I don't know the detail, but I know that they put it here. Now look, if the pacemaker body is made up of some material which is not biocompatible, which is not friendly with the human body, then what will happen? After a few days, maybe it will react with the human tissues, with the blood, with anything, and it can make another chemical in the human body, right? Or it may harm the human body somehow. So then it will not be good, right? It will have adverse effect. So for that purpose, we need some material which are biocompatible, which are friendly with the human tissue, like they will not react with the human tissue. Those materials are known as what is biomaterial. And now even recently the new pacemaker or the brain pacemaker has also came. Some patient, they have some brain problem, the epilepsy patient, I think. So they put a pacemaker inside the human skull here somewhere, and it provides pulses to the human brain to keep it like the activity normal. So, and all these are the example. You see here, we have the joint replacement. This is the new material, right, which have been replaced in this joint. The hip joint replacement. So this is the new material which have been replaced here. And we have heart walls, we have the dental implants, different, right? Some, even the repair devices, skin repair devices, all these things which we are using, and even the wire which the doctors are using for stitching purposes, you know, it should be friendly with the human, with the human tissues and everything, right? So, and now there are a lot of gadgets. If you search it, there are a lot of biomedical devices have been come. They put it in, they put all the devices within the human body, and they don't have any adverse effect. And it is possible because of what? Because of these biomaterials, right? So biomaterials are mainly those types of materials, right? We have the smart material. All these are advanced material, right? Which I like categorize the fifth category somehow you can say of the material. Now smart material, the word smart here we mean that they are intelligent, right? Now by intelligent, it doesn't mean that these materials will sit and solve your exam, right? They will not solve your exam and they cannot. They are not that intelligent here doesn't mean that thing. Now by intelligent or smart word, we mean here what? We mean that these material sense changes in their environment. If you have a material and something happens in its environment, this material will sense that. That's why they are smart and that's why they are intelligent, right? Now, the example of this is the shape memory alloy. Shape memory alloy, or another example is piezoelectric ceramic, magnetostatic material. The shape memory alloy, what happens to the shape memory alloy? If you have a shape memory alloy and this material is made, let's say, of shape memory alloy, and it is straight. If, let's say, the temperature change is here, it will bend like this. And then if the temperature, let's say, previously if it goes high, now it goes down, so then it will become again straight. Like if you have a material, the shape memory alloy, it is straight. If the temperature change, let's say the temperature goes high, it will bend maybe. It can take any shape, depends on which shape memory alloy are you using. And after some time, when the temperature becomes normal, it will become straight again. So now this material, it senses the temperature change around it in its environment. And this is very, very important that the material is sensing the temperature. Based on this, you can say phenomena, we can design a lot of things. We can use this material for different types of application, right? Here is one example. You see here the stent made up of shape memory alloy. They put it here, the stent. So different types of applications are there. The piezoelectric material, which is another smart material, what does it do? The piezoelectric material, actually, this material, we will study this piezoelectricity and the electrical properties in a very detailed way, but today I will give you just a brief overview. Now the piezoelectric material, inside the piezoelectric material, it has dipoles, right? Dipoles mean they have like, let's say this is the piezoelectric material, right? And it has dipole, it has two charges, the single dipole like plus and minus, right? So these dipoles are there, plus and minus. So different dipoles are inside the material, right? The piezoelectric material. They are randomly arranged. Like there is no proper order in this part. When I force this material, when I force this material, let's say I apply a force on the material. When I apply a force on the piezoelectric material, what happens actually? These dipoles, they arrange themselves in proper order. Like, let's say we have this order. The proper order, right? So all here we have negative and we have positive here. So when they arrange all these dipoles arrange themselves in the proper order, what happens? The potential difference created. Because all the negatives are here and the positive are here. And if you connect wire here and wire here, you will have a voltage. It will give you electrical energy. So these piezoelectric material are now commonly used in the, you might have heard the word piezoelectric energy harvesting. Energy harvesting, what they do, they, in the piezoelectric specifically, they use this piezoelectric material to harvest energy from the some motion. If I have a piezoelectric strip, this is the piezoelectric strip, let's say, and due to, let's say, some vibration, some motion, this vibrates. So continuously there is a force on it. And if I have connected with something, so I will get electrical energy from it. So this is the smart characteristics of the material, right? Free energy it is giving to you. While on the other side, if you reverse this process, what will happen? By reverse, I mean, if you are not applying force on the piezoelectric material, but you are giving electrical pulses to the piezoelectric material, right? If here you put a battery, right? Plus minus, you put a battery and you give electrical pulses to this material. So if you give electrical pulses to the material, it will move, right? If you have the piezoelectric material, you give electrical pulses, it will move up and down. Depends on the pulses, but it will move. So this is the characteristics of the material, and that's why we call it smart material. So both way it works. If you force it, it will give you energy. If you give energy, it will move. Like you can deform it by providing electrical pulses. The third one is magnetostatic material. This material behaves similar to the piezoelectric material, but in addition to the piezoelectric behavior, they are stimulus to the magnetic field also. So when you put it in the magnetic field, it will be attracted and it has the magnetic behavior, right? And all the piezoelectric properties are here available in the magnetostatic. But in addition, it is stimulus, or you can say it is responsive to the magnetic field also. So these are smart materials, right? Now we discuss different types of material, the metal, the polymer, the ceramics, the composite material, and then we discuss different types of advanced material. Now all these materials are available to us in the society to use, but it doesn't mean that whatever material we need is available. Still there is a big need of more material, more advanced material we need, right? So don't think like every material we need is available and just go to the market. No, we need to do research. Still we have to do experimentation and all these things to develop or to modify the material property, right? I will give you a few examples here where we need the new material, right? But you can find thousands of things where we need the new material. You might have heard the word the nuclear energy, right? Which is a little like more cleaner energy than the fossil fuel, the coal, the oil, and all these. The nuclear energy is clean energy, and it will be good if we use the nuclear energy, the whole one. But why we are not using? There is some problem, right? The problem is, no, the sun is a different thing. We are coming to the sun. Just wait. So the problem with the nuclear energy, what is the problem? When you use the nuclear, it is a fuel, and you take energy from it, then you have some waste which is coming from the power plant, like the nuclear power plant. That waste is radioactive, right? And it is very difficult to dispose that waste. How to dispose it? This is a big problem. That's why majority of the countries is not using the nuclear power, although they have, but they are not using for the electricity generation, right? Why? Because they don't know how to dispose. They don't have the technology to dispose the radioactive waste. And if you do not have the technology, you don't know how to properly dispose it, then it will have adverse effect on the human life. And you might have heard in the history, there were a lot of accidents happen in the Japan, in the Russia, the Chernobyl. There is even one movie, the Chernobyl, a small series, but you can watch it, that one also. So still there are problems with the human. Why? Because there was some leakage and all these things. If let's say today or tomorrow you people develop a material in which if you put this waste, the radiation will not come out. So that material, if it blocks the radiation, then everybody will use the nuclear energy, right? So we need some material there. Now other materials we need, like for your car, the aeroplane, whatever material we are using, either iron, steel, or whatever, any other alloy. If tomorrow you have an alloy or new material which have the same strength but less weight, the mass, the weight of the material is less, then every automobile company will use that one, because the fuel consumption will be less, the speed will be more, the more comfort will be there. Less, even if the fuel consumption is less, so low cost it will charge. And it will be good for the aeroplane, the trains. Now increasing engine operating temperature will enhance fuel efficiency, but we need some material to withstand with that temperature. So new high strength, low density structure material remains to be developed. Like low density and high strength material, we need to develop those materials. Now, one of you talked about the sun, the solar energy. So I will give you example. The solar energy, how we are using. We are just buying solar cell, the solar panel, which you can say the panel, from the market, and we put it in our house, and we are having the solar energy. But do you know what is the efficiency of that solar cell or the panel which you buy from the market? What is its efficiency? Any one of you know? How much is the efficiency of the solar panel? Yeah, by percentage, I mean, yes. How much percentage? 20%, yes. Like from 18 to 25, maximum you can say 25, 24. Now, is it a good efficiency? This is not, right? So it means if from the sun 100 watt per meter square energy is coming, let's say the irradiance is 100 watt per meter square. If we have 1 meter square solar panel and it falls on that solar panel, so 20 it will take and the remaining 80 will be lost. So for that reason, we need bigger lands, right, to harvest more energy from the solar. So that's why still it is okay, people are using it. But if we have higher efficiency, then you might have, let's say, 1 meter solar panel and it will work even for your home. You don't need a big park for it, which nowadays you might have seen the solar parks people are making. Why? Because the efficiency is low. And how we can improve the efficiency? By making new material, by developing new material. If tomorrow we have a new material from which we can make solar panel, the solar cell, and if its efficiency is even 30, 40%, everybody will buy that material and we will throw all the old one. You know, so there is a need of all these new materials which we have to develop. Right? So don't be discouraged that every material already it is available in the world, and what we will do. There is a huge gap. You can work on it, and tomorrow you can serve your community, your society in some way. So this is all about the materials introduction, right? And for today's class. For self-study, yeah, there are some materials of the future. You have to study it on the internet: graphene, aerogel, metallic glass, electronic textile, right? Transparent aluminum, regenerative material. These are, I just put it for you. You have to study on internet, and you will see that these material people are working on it, and some of them are already available in the market, and it will have a good application in the human life.